And then people realized, oh my God, it's a volcanic eruption.
We found that it's covered with volcanoes. It is tremendously geologically active. There are volcanoes erupting all the time.
Diving straight into the heart of cosmic exploration, the saga of Voyager 1 and 2 unfolds, a narrative that stretches the fabric of human achievement and curiosity to its limits. Conceived over 40 years ago for a brief 5-year quest, these interstellar voyagers have shattered their expiry date, continuing their silent dance through the cosmos. Their odyssey has not just extended beyond the expected, it has expanded the realm of the known, challenging and reshaping our comprehension of the universe. As we weave through 10 pivotal revelations brought back by these distant explorers, we probe the mysteries they've uncovered. How do these findings redefine our understanding of space and time? What hints do they offer about the elusive concept of extraterrestrial life? And most intriguingly, what questions do they compel us to ask next? The legacy begins. In the late 1970s, a momentous event unfolded that would redefine humanity's quest to understand the cosmos. NASA's Voyager 1 and 2, embarking on an unprecedented journey, marked the beginning of an enduring legacy in space exploration. Crafted with precision and foresight, these spacecraft were not just machines but beacons of human curiosity, destined to traverse the unknown. The timing for their launch was strategically chosen to leverage a once-in-175-year planetary alignment, an astronomical window that provided a unique slingshot effect. This alignment allowed the Voyagers to undertake a grand tour, a path meticulously charted to swing them by Jupiter, Saturn, Uranus, and Neptune, with minimal fuel consumption, thanks to gravity assists from these planets. The significance of this timing cannot be overstated. It was a narrow launch window that offered a shortcut through the solar system, turning a potential millennia-long journey into a feasible decade-spanning mission. Engineered to endure the harsh conditions of space and the unknown variables of the outer solar system, Voyager 1 and 2 were equipped with a suite of scientific instruments designed to study everything from atmospheric properties to magnetic fields, from the composition of planetary rings to the physical characteristics of moons. These instruments, revolutionary for their time, were the eyes and ears of humanity, stationed on the very frontier of our cosmic neighborhood. The mission's objectives were as vast as space itself. Beyond the primary goal of exploring the gas giants and their moons, the Voyagers were tasked with answering questions about the heliosphere, the bubble-like region of space dominated by the solar wind and magnetic field of our sun, and the very nature of the interstellar medium. What they found not only exceeded expectations, but also raised new questions that scientists hadn't even thought to ask. As these spacecraft ventured into the void, crossing the boundary of our solar system, they carried with them the golden record, a message in a bottle cast into the cosmic ocean. This record, a 12-inch gold-plated disc, carries sounds, music, images, and greetings in multiple languages from Earth, a testament to the diversity and creativity of life on our planet, intended for any extraterrestrial intelligence that might find it. Today, decades after their launch, Voyager 1 and 2 continue to communicate with Earth, sending back data that challenges our understanding and expands our knowledge of the vastness that surrounds us. As we reflect on the legacy of these pioneers, we must ask ourselves, what does their journey tell us about our place in the universe? How have these distant emissaries changed our perspective on exploration, discovery, and the innate human desire to reach beyond our grasp? The Voyager's design and lifeline. The design and lifeline of Voyager 1 and 2 are a marvel in the history of space exploration, embodying human ingenuity and our relentless pursuit of knowledge beyond the familiar confines of Earth. At the heart of their enduring legacy is a combination of groundbreaking technology and innovative engineering, enabling these spacecraft to communicate with Earth from billions of miles away and to continue their journey into the unknown depths of space. The high-gain antenna, a critical component, serves as the Voyager's lifeline to Earth. This sophisticated piece of equipment, measuring about 3.7 meters in diameter, is responsible for transmitting the wealth of data collected by the spacecraft back to eager scientists on Earth, as well as receiving commands from the NASA Deep Space Network. The precision with which this antenna operates is crucial, given the vast distances involved, ensuring that even the faintest whisper from the edge of the solar system can be captured. But what powers these distant Voyagers? The answer lies in the radioisotope thermoelectric generators, RTGs, a source of power that seems almost as science fiction as the mission itself. These RTGs harness the heat released by the decay of plutonium-238, a radioactive material, converting it into electricity that powers the spacecraft's instruments, computers, and communication systems. Initially designed to produce 470 watts of power, these generators have exceeded expectations, demonstrating a resilience that has allowed the Voyagers to continue their mission decades beyond their intended lifespan. This ingenuity is not just about sustaining power, it's about sustaining hope and curiosity. The gradual decrease in power output has been anticipated and managed through the careful shutting down of non-essential systems to preserve the Voyager's ability to send back invaluable data. Every watt saved is another opportunity to deepen our understanding of the universe. The robust design of the Voyagers speaks to a broader theme of exploration and discovery. These spacecraft were built not just to survive, but to thrive in the harsh environment of space, to venture into the unknown, and to keep communicating their findings back to us across the unimaginable void of space. Their ongoing mission is a testament to human ingenuity and our insatiable desire to explore the cosmos. How have these designs held up against the expectations of their creators? What lessons have engineers and scientists learned from the resilience and performance of the Voyager systems? These are questions that continue to intrigue and inspire as the Voyagers, against all odds, keep pushing the boundaries of human achievement. Revolutionary discoveries. The Voyager's journey beyond the familiar confines of Earth brought into focus a universe more intricate and dynamic than we ever imagined. As these spacecraft ventured past Jupiter, they revealed a planet swirling with storms and surrounded by a retinue of diverse moons, each harboring secrets of their own. Io's volcanic fury, Europa's icy shell hinting at an underground ocean, Ganymede, the largest moon in the solar system, and the mysterious Callisto, invited us to rethink what worlds beyond our own could look like. Saturn's elegance was unveiled in unprecedented detail, its majestic rings casting new light on the dynamics of planetary systems. The Voyagers provided a closer look at the icy particles composing these rings, their sizes ranging from micrometers to meters, showcasing a complex system governed by gravitational interactions. Uranus and Neptune, though less explored, were no less spectacular. Uranus revealed itself as a tilted giant, its axis so extreme that it essentially orbits the sun on its side. This peculiar orientation leads to extreme seasons, drastically altering our understanding of planetary climates. Neptune, with its fierce winds and dark spots, challenged our notions of weather systems in the outer solar system. The dance of the planet's moons, each following its unique path around these distant worlds, has provided a ballet of celestial mechanics for scientists to decode. From these observations, we've learned about tidal forces, resonances, and the gravitational ballet that keeps these systems in order. Yet, with every answer gleaned from the Voyager's journey, new questions have emerged. How do these outer planets form and evolve? What can they tell us about the origins of the solar system? And perhaps most tantalizingly, could any of these moons host life within their icy or volcanic depths? the Voyagers have turned what was once a distant, static view of our solar system into a dynamic, evolving tableau, rich with possibilities for future exploration. As we continue to analyze the wealth of data they've provided, we stand on the brink of even more revolutionary discoveries about our place in the cosmos. Beyond the known, Voyager 1's historic journey. Voyager 1's journey is a tale of ambition, soaring past the boundaries of our solar system to the uncharted territories of interstellar space. This craft, a marvel of human engineering and curiosity, ventured where no probe had before, bringing the universe closer to our grasp. Its trajectory past Jupiter and Saturn was not just a path through space, but a journey through the wonders and mysteries of our cosmic neighborhood. As Voyager 1 approached Jupiter in 1979, it turned its array of instruments towards the giant planet and its moons. The images sent back were nothing short of revolutionary, unveiling Jupiter's tumultuous atmosphere, its intricate ring system, and providing unprecedented views of its moons. The Great Red Spot, a massive storm larger than Earth itself, was seen with clarity that astounded scientists and laypeople alike. But perhaps even more groundbreaking were the close-up images of Io, revealing its volcanic activity, an unexpected window into the geologic vitality of another world. The encounter with Saturn was equally transformative. Voyager 1's flyby in 1980 offered humanity its first detailed views of Saturn's rings, a spectacle of cosmic artistry and physics. The probe's cameras captured the intricate structure of these rings, along with the haunting beauty of Saturn's moons, including Titan, which held, and continues to hold, fascination for its thick atmosphere and the potential for harboring liquid bodies on its surface. But Voyager 1's mission was far from over after these encounters. In a bold move, NASA directed the spacecraft towards the edges of our solar system and beyond, towards interstellar space. This phase of its journey was aimed at exploring the boundaries of the sun's influence, where the solar wind dies down and the vastness of interstellar space begins. In 2012, Voyager 1 crossed the heliopause, the boundary at which the solar wind is stopped by the interstellar medium, officially entering interstellar space and marking a historic milestone in human exploration. This leap into the unknown was not just symbolic. Voyager 1 began to transmit data about the conditions of space in regions never before directly observed by human-made objects. The information it has sent back about cosmic rays, interstellar magnetic fields, and the density of space outside our solar bubble provides invaluable insights into the nature of our galaxy and the universe at large. Voyager 1's historic journey raises profound questions about what lies beyond the familiar confines of our solar system. What mysteries await in the vast, unexplored stretches of our galaxy? How will the data Voyager 1 continues to send back reshape our understanding of the cosmos? And what does this journey tell us about our place in the universe? As we continue to receive signals from this distant messenger, each piece of data is a reminder of the audacity of human curiosity and our unending quest to reach beyond the known. The enigma of Io's volcanoes. Voyager 1's close encounter with Io, Jupiter's innermost Galilean moon, unveiled a world unlike any other in our solar system, marked by extraordinary volcanic activity. This moon, with its surface punctuated by over 400 volcanoes, presented a spectacle that defied prior astronomical predictions and theories. Among these, the Loki volcano stood out, not just for its size or strength, but for its sheer unpredictability and activeness, mirroring the chaotic and mischievous nature of its mythological namesake. Io's volcanism is fueled by tidal heating, a process driven by the intense gravitational tug-of-war between Jupiter and its moons. This gravitational kneading warms Io's interior, melting its rock into magma and enabling volcanic eruptions that are both violent and spectacular. The heat generated is so immense that it turns Io into the most geologically active body in the solar system, a title that was unimaginable before Voyager 1's revelations. The implications of these findings extend far beyond Io itself. They challenge our understanding of how celestial bodies evolve and behave, introducing new variables into the equations that describe planetary systems. This moon, with its fiery temperament and dynamic surface, serves as a natural laboratory for studying geological processes under extreme conditions. But why does this matter? Io's volcanic activity provides key insights into the interplay between gravitational forces and geological phenomena. Understanding this relationship not only broadens our knowledge of the outer solar system, but also deepens our comprehension of Earth's own geologic activities. Furthermore, the peculiarities of Io's volcanoes, especially the enigmatic Loki, offer a captivating puzzle. Why does Loki's eruptive schedule vary? What does this tell us about the moon's internal structure and volcanic mechanisms? These questions beckon the curious mind, promising answers that could unlock new frontiers in planetary science. As we delve into the mysteries of Io, we're reminded of the universe's capacity to surprise us, pushing the boundaries of what we know and challenging us to think deeper about the cosmos. Voyager 1's journey past Io was not just a flyby, it was a paradigm shift, urging us to reconsider our place in the universe and the dynamic processes that govern it. Unveiling Uranus and Neptune, Voyager 2's contributions. Voyager 2's grand tour through the solar system delivered us directly to the frontiers of the unknown, especially when it came to the icy giants Uranus and Neptune. Before Voyager 2's flybys, our understanding of these distant planets was limited to telescope observations, leaving much to the imagination. But as Voyager 2 approached Uranus in 1986, it turned imagination into revelation. At Uranus, Voyager 2's array of instruments peeled back the veil on a world strikingly different from its planetary siblings. It unveiled 10 previously undiscovered moons orbiting the planet, each with its unique characteristics and mysteries. These moons ranged from heavily cratered surfaces indicative of ancient cosmic collisions to smooth, icy ones, suggesting internal activities or recent resurfacing. Voyager 2's discovery of new rings around Uranus was equally groundbreaking. Prior to its arrival, the existence of Uranian rings was speculated but unconfirmed. The spacecraft's images and data provided undeniable evidence of this intricate ring system, revealing the ring's composition and dynamics. The journey didn't stop there. Voyager 2 pressed onward to Neptune, offering humanity its first close look at this deep blue planet in 1989. Here, the probe's findings were just as stunning. It confirmed the existence of a dynamic atmosphere, capturing images of raging storms and high-speed winds, some moving at speeds of more than 2,000 kilometers per hour. Voyager 2 also detected signs of Neptune's complex weather patterns, including the Great Dark Spot, a storm comparable to Jupiter's Great Red Spot. Perhaps most captivating was Voyager 2's discovery of 4 additional moons and the confirmation of Neptune's faint ring system, which had eluded astronomers for years. These rings, made of dust and ice particles, underscored the diverse and dynamic nature of the outer solar system's planetary ring systems. Each discovery by Voyager 2 at Uranus and Neptune offered a window into the processes that govern the outer solar system, from the formation of moons and rings to the atmospheric dynamics of ice giants. Through its encounters with Uranus and Neptune, Voyager 2 reshaped our understanding of these distant worlds. It painted a picture of dynamic systems where moons are born and weather rages across vast distances. The data it sent back has fueled decades of scientific inquiry and will continue to do so for years to come. What mechanisms drive the formation of rings? How do ice giants' atmospheres differ from those of gas giants like Jupiter and Saturn? Voyager 2's legacy is a testament to human curiosity and our quest to understand the cosmos. What further secrets will unravel from the depths of Uranus, and Neptune as we continue to analyze Voyager 2's treasure trove of data. The Zeta Ring Mystery. In the vast silence of space, the Voyager 2 spacecraft unveiled a cosmic puzzle that has perplexed astronomers and challenged our understanding of planetary ring systems. Upon its approach to Uranus, Voyager 2 documented a phenomenon that seemed to defy the established norms of celestial mechanics. The Zeta Ring, a faint and elusive band encircling the planet, appeared to vanish before the eyes of the scientific community, only to re-emerge in later observations. This mysterious disappearance and subsequent reappearance raised a flurry of questions about the stability and dynamics of planetary rings. Planetary rings, those delicate bands of dust, rock, and ice orbiting planets, have long been a subject of fascination. They're not just beautiful cosmic ornaments. They are windows into the history and inner workings of our solar system. The dynamics of these rings, how they form, evolve, and sometimes seem to play a game of cosmic hide-and-seek, hold crucial clues to the gravitational forces at play and the processes shaping the environments around planets. The Zeta Ring's vanishing act prompted scientists to delve deeper into the gravitational interactions between Uranus's moons and the dust particles comprising the ring itself. They speculated that the gravitational pull from the moons could be responsible for dispersing the particles, making the ring temporarily invisible or, alternatively, concentrating them, leading to its reappearance. This theory suggested a dynamic and changing nature of planetary rings influenced by a complex ballet of gravitational forces. Moreover, the phenomenon hinted at the presence of unseen shepherd moons, whose gravitational forces could be sculpting the rings, corralling particles into a denser formation at certain times and spreading them out at others. This revelation opened up new avenues of research, pushing astronomers to rethink how they model the interactions within ring systems and the role of moons in their formation and maintenance. The Zeta Ring mystery also underscored the importance of long-term observational campaigns. As planetary rings can exhibit changes over relatively short astronomical timescales, continuous monitoring is key to understanding their behavior. This incident has bolstered the case for future missions to Uranus and the outer planets, to deploy more advanced instruments that can watch these rings evolve, reveal their secrets, and perhaps unravel the forces that govern their fleeting existence. What does the Zeta Ring's disappearance and reappearance tell us about the unseen forces at work in the outer reaches of our solar system? Could this phenomenon be more common among the gas giants than previously thought? And what other mysteries are lurking in the shadows of these distant worlds, waiting to be discovered by the next generation of space explorers? The Voyager 2's encounter with the Zeta Ring of Uranus has not just expanded our knowledge, it has magnified our curiosity, reminding us that the universe is full of wonders, many of which are yet to be understood. Interstellar ambassadors. Embarking on an unprecedented journey, Voyager 1 and Voyager 2 serve as humanity's emissaries to the unknown, each bearing a golden record, a cosmic message in a bottle. These records, crafted from durable gold-plated copper, are time capsules, meticulously designed to outlive humanity itself. Encased in protective aluminum jackets, they carry the essence of Earth. 115 images, a myriad of natural sounds from our planet, music from different cultures and eras, and greetings in 55 languages. Imagine, if you will, an alien civilization millions of years in the future, stumbling upon one of these spacecraft drifting through the interstellar void. Upon discovering the golden record, what would they learn about us? They'd encounter the sounds of Earth's nature, thunderstorms, the roar of the sea, the chirping of birds, and the haunting call of the humpback whale. They'd hear the laughter of a human, the footsteps, a heartbeat, an intimate glimpse into the life that thrives on our blue dot. The music selection is a testament to humanity's diversity and creativity, ranging from Bach to Chuck Berry, from Guanpinghu to Beethoven. These melodies, transcending language and culture, might be the first encounter this extraterrestrial civilization has with human artistry and emotion. But the records carry more than just sounds and music. They also hold greetings from Earth's inhabitants, spoken in dozens of tongues. This gesture of saying hello in so many languages embodies a unified desire to connect, to reach out across the cosmos and touch the unknown. And the images, these snapshots of Earth and its inhabitants, offer a panoramic view of our existence. From diagrams of DNA structures to photos of iconic landmarks and everyday scenes, these images catalog the breadth of human experience and the natural beauty of our world. In sending the Voyagers into the cosmos equipped with these golden records, humanity has cast a bottle into the cosmic ocean. It's a declaration of our existence, an invitation to communicate, and perhaps most poignantly, a testament to our longing to find kinship in the vastness of the universe. So, as these interstellar ambassadors continue their silent journey through the void, one can't help but ponder, what if one day the record is found? What will those who discover it think of us? Will they marvel at the complexity and beauty captured on this golden disk? And could this mark the beginning of an interstellar conversation, proving that we are, indeed, not alone in the universe? Signals from the Edge Voyager 1 has been our eyes and ears in the void, transmitting data that has reshaped our understanding of the universe. But decades after its grand departure, something unexpected began to unfold. The spacecraft, now billions of miles from Earth, started sending back signals that puzzled the brightest minds back home. These weren't the crisp packets of data scientists were accustomed to. These were anomalies, deviations from the norm that defied immediate explanation. What could cause such aberrations in Voyager 1's transmissions? Initial thoughts leaned towards technical malfunctions, a reasonable assumption given the spacecraft's age and the harsh conditions of space. Over time, components can degrade. Cosmic radiation can wreak havoc on electronic systems. Yet, the spacecraft's health checks, sent back to NASA, showed everything operating within expected parameters. The mystery deepened. This led to a cascade of questions and theories. Is Voyager 1 encountering phenomena beyond our current scientific understanding? The regions of interstellar space are filled with unknowns. Could the spacecraft be brushing against the boundaries of our heliosphere, where the sun's influence wanes and the interstellar medium takes over, presenting conditions we've yet to fully grasp? Speculation ventured further into the realm of science fiction. Some pondered if these signals could be the first faint whispers of extraterrestrial intelligence. An enticing thought, though without evidence, remains firmly in the realm of speculation. Still, the idea of our distant messenger stumbling upon a cosmic conversation captures the imagination. Scientists continue to analyze the signals, piecing together the puzzle left by Voyager 1. Each transmission is a voice from beyond, a reminder of the vast unknowns that lie ahead. As we stand on the brink of cosmic discovery, these signals from the edge beckon us to look deeper, question further, and dare to dream of what lies beyond the familiar glow of our star. What will Voyager 1 reveal next in its journey through the shadows of space? The answer lies in the silent signals drifting across the cosmos, waiting to be decoded. The legacy continues. The dwindling power supply of the Voyagers serves as a stark reminder of their mortality, and, by extension, our own. Yet, even as they venture further into the silence, their legacy is anything but quiet. Each signal, every piece of data sent back to Earth, is a beacon of human achievement, echoing across billions of kilometers of empty space. What does it mean for humanity, knowing that pieces of our creativity, our knowledge, and our questions are out there, sailing through the stars, long after the lights on their consoles fade? The Voyagers, in their relentless voyage, challenge us to look beyond the immediate, beyond the lifespan of a battery or even a civilization. They remind us of the power of curiosity and the drive to explore, attributes that have propelled humanity from the confines of Earth to the great expanse of space. In many ways, the journey of the Voyagers parallels our own quest for meaning and connection in a universe vast beyond comprehension. What dreams might they inspire in future generations? What distant shores of knowledge might we reach, driven by the trail they've blazed? As they drift into the cosmic ocean, the Voyagers ensure that the story of human ingenuity, curiosity, and hope will not be confined to this planet or this epoch. In the grand tapestry of the cosmos, the Voyagers are but a thread, yet they embody a profound message: that the desire to explore, to learn, and to connect is as boundless as the universe itself. As we peer into the night sky, we're reminded that part of us is already out there, journeying into the eternal night, a testament to our small but significant place in the cosmos. The Voyager missions embody humanity's greatest aspirations and remind us of the vast, unexplored cosmos that lies beyond our grasp. As we ponder the signals from Voyager 1 and contemplate the future of space exploration, we stand on the precipice of boundless possibilities. The legacy of Voyager 1 and 2 continues to inspire us to look beyond our cosmic shores, seeking answers to questions we have yet to ask. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now for more engaging content like this.